Hello everyone, welcome back to another Leetcode problem solving session. Today we're doing the problem of the day for April 27th. It's called bulb switcher. So there are n bulbs that are initially off. You first turn on all the bulbs, then you turn off every second bulb. On the third round, you toggle every third bulb, turning on if it's off or turning off if it's on. The ith round, you toggle every ith bulb, or toggle every eye bulb, and then for the nth round, you only toggle the last bulb. So essentially, you toggle, you go through every bulb and you turn it on, and then you turn every other one off, and then every third one you turn back on, or I guess you would toggle it. It's not necessarily turning on or off at that point. So this is actually not too much of a coding problem, but more of a math problem. Actually, we'll look at this first example. N equals 3. So you can see that after the 3 rounds, just the first one is on, and the second and third ones are off. So the first round, we turned second one and third one on, and then the second round, we turned the second one off, and then we never touch it again, because after that, it's the, every third and every fourth. Well, we're never going to touch the second one again. We've gone through all of the rounds that could possibly touch the second one. And for the third one, we turn it on in the first round and we turn it off in the third round. Essentially what you do is you turn it on or off in the rounds where the round number divides the number of the bulb itself. So 1 and 2 divide 2. So in rounds 1 and 2, we would turn off, toggle the light bulbs on or off. So we have to think, okay, well, if there's an even number of factors, then clearly we would have the bulb off by the end of it. Whereas if there's an odd number of factors, then we would have it on, because, on, off, on, off, on, off, and then one more for on, that would be an odd number. So when does a number have an odd number of factors? Well, when you think about it, every number, if you were to divide by, let's say 1, you would have a corresponding, let's say the number n. If you divide n by 1, you would be left with n, and that's the corresponding factor. You can kind of pair up each factor that a number has. So for, let's say 8, yeah, 8's a good example. We would have 1 and 8, and we would have 2 and 4. So that is an even number of factors. So if n is at least 8, then we know that we will have an even number of factors for 8, and this bulb will be turned off by the end of it. Let's look at 9. Well, 9 has 1 and 9, and then 3 and 3. So these are duplicates here, which means it actually has an odd number of factors. And you'll notice the only time you'll have duplicates is when a number is a square. So essentially what we're doing is we're counting the number of squares up to n. Well, if we square root something like 9, we'll get 3. So knowing that 9 equals 3 squared tells us, well, we've gone through 1 squared, 2 squared, and 3 squared to get to 9. So all we have to do is simply return the square root of n, right? Well, then you still have the case. Sorry, let me just import some stuff from math. But let's say you have n equals 10 in this case. Well, square root of 10 is not even an integer, so that's not going to work for this. So what we do is we actually have to take the floor, because essentially everything, all of the squares up to 10 are the ones that will be turned on by the end of the 10 rounds. So we would have 1, 3, and 9. So there's the 10 bulbs on after the first round. round 1, after round 2, this is after round 2, this is after round 3, this is after round 4, this is after round 5, this is round 6, this is round 7, after round 8, after round 9, and after round 10. So as you can see, the only ones that are turned on are the squares, the 1, 4, and 9. So if we just take the number of squares less than or equal to n, then we should have the solution. Perfect. Thank you guys so much for watching. If you guys have any questions about the solution, please let me know in the comments. Also, please like and subscribe, and I'll see you guys next time.